In this video, we're going to cover section 1.4, trigonometric functions, the unit circle. So some of you are probably familiar with the unit circle. A unit circle always has a radius of 1, meaning 1 unit, so that's why we call it the unit circle. And the center is at the origin of the rectangular coordinate system, so at 0, 0. The equation of this circle is x squared plus y squared is equal to 1. And that should look familiar, right? In the previous section, when we weren't necessarily assuming we were working with a unit circle, but remember in the previous section, here's x, here's y, and we had some point P, right? X comma y. It's a little crooked. Let's make that better. Such that when we formed angle theta, the terminal ray went through the point P, x comma y. And what I had you guys imagine was that theta lives in a right triangle, right? Whose base, the length of the base is x, and whose height was y. And the hypotenuse represented the radius of the circle, right? So imagine this circle that ray is intercepting at point P. So we said that, let's just, for example, sine theta, cosine theta, tangent theta, right? So based on this triangle, we said that sine theta, we know it as opposite over hypotenuse, but opposite of theta is y, right? So that would be y over r, which is the hypotenuse in this case. Cosine theta was x over r, and tan theta was y over x, right? Assuming radius r. And based on the Pythagorean theorem, x squared plus y squared was equal to r squared, right? Leg squared plus leg squared equals hypotenuse squared. But in a unit circle, the radius is 1. Therefore, we're going to have x squared plus y squared equals 1 squared, which is just 1. And that's the equation of the circle. So let's focus on this unit circle right here. The radian measure of this central angle is equal to the length of this arc. You see S is the arc length. So this angle, right, created, or it made this intercepted arc, right, where I'm coloring in blue. So that length is equal to the angle that's formed. So T is equal to S, assuming the radius is 1. So if my radius is 1, then think about what these ratios are going to be equal to. Y over r for sine would be y over 1, right? Because the radius is 1 in a unit circle. So sine theta would just be equal to y. Cosine theta would be equal to x over 1, which is x. And tan theta equals y over x. But since r isn't part of that ratio, right, it's going to stay the same, y over x. And that's what we have down here. So in this diagram, we're given the angle measure and the arc length are given, a real number. So we're calling this angle t. So the sine of t is equal to y, the cosine of t is equal to x, and the tangent of t is equal to y over x, where x can't be 0. And then we have our reciprocal functions. So what this means is if t is a real number and p is equal to some ordered pair x comma y, and that's a point on the unit circle that corresponds to t, then we could identify sine, cosine, and tangent using these values. And then, of course, the reciprocal functions. So let's look at an example. So for example, in example 1 here, you see how we have this unit circle. And the reason I know it's a unit circle, so let's kind of review the unit circle for a minute. So if I have a unit circle and the radius, right? So the middle of the circle is at 0, 0. So if the radius is 1, right, we're going to go out a distance of 1. So let's say that's the point 1, 0. Here's the point 0, 1. Here's the point negative 1, 0. And here's the point 0, negative 1. And I know this is an ugly not to scale drawing, but you see how the circle goes through 1, 0, 0, 1, negative 1, 0, and 0, negative 1, making the radius 1. So those are the points that the circle is always going to go through when we're talking a unit circle. Now, one of the points that's going to lie on this unit circle, like I have in the example to the right, is the point radical 3 over 2, comma 1/2. So that's this point right here on the unit circle. The x value is radical 3 over 2. The y value for that point is 1/2. And we're forming this angle t, and the arc length is also equal to t because the radius of this circle is 1. You see how the circle is going through 1, 0, so we have the unit circle. This point up here is going to be 0, 1. This point over here is negative 1, 0, and this point down here is 0, negative 1. So what is the sine of t of this angle that's being formed in this right triangle? Not right triangle, in the angle that's being formed, that's intersecting this unit circle. So sine t, remember, is equal to y over r, but if r is equal to 1, it's just y. So sine t, in this case, the sine of this angle is whatever the y value is, right? Whatever the y value is in this ordered pair. So it's going to be equal to 1/2. Now, cosine of t is equal to x. And all I'm doing is using these definitions up here. And the x value, so this is y, and this is x, the radical 3 over 2. So cosine of t is going to be equal to radical 3 over 2. And then the tangent of t is going to be equal to y over x, which is 1/2 over radical 3 over 2. And that's equal to 1/2 times the reciprocal. So 2 over radical 3, and that's going to be 1 over radical 3. And if we rationalize the denominator by multiplying the top and the bottom by rad 3 over 3, we're going to end up with radical 3 over 3 for tan t. These values should look familiar. So I'm going to share my screen and go back to the section 1.2 worksheet. So remember this table. You see how we have in this case, the sine of t is equal to 1/2, and the cosine of t is equal to radical 3 over 2. And the tangent was radical 3 over 3, right? Aren't these the values that we just got that I just circled for sine, cosine, and tangent? That corresponds to an angle of 30 degrees or pi over 6 radians. And that's the angle that's formed when we have a unit circle and our terminal ray intersects the point radical 3 over 2, comma 1/2. So even though I wasn't asking for what the angle was, I was just interested for finding the values of the trigonometric functions at t, but I just want you to make the connection. So let me give you another example. So let's say, let me just go to a blank slate for a minute. So let's say I have my unit circle. So here's the point 1, 0. And let's say we form an angle T, and it's going to intersect the circle at the point radical 2 over 2, comma, radical 2 over 2. So let's find the sine of t, the cosine of t, and the tangent at t. So remember, sine t is equal to y. And the y value in this ordered pair, right, at that point is radical 2 over 2. So the sine of t is equal to radical 2 over 2. The cosine is going to be the same. So cosine t is equal to x, but x is also radical 2 over 2. And then tangent of t is y over x. So we're going to have radical 2 over 2 over radical 2 over 2. And whenever we have anything over itself, right, that's just equal to 1. These values should look familiar also. Let's go back to the worksheet, the 1.2 worksheet. Look, you see how I have sine is equal to radical 2 over 2, cosine theta is radical 2 over 2, and tan theta is equal to 1. That's for a 45-degree angle, or pi over 4 radians. So this angle that we just formed here, T, happens to be a 45-degree angle. Again, I'm not asking you to solve for that, but I want you to make the connection. And that's where these values in the table are coming from, right? So we use those special triangles, but it all relates back to this unit circle. So let's look at another example. Let's use the unit circle to find the following values: the sine of 0, the cosine of 90, the tangent of 270, the cosine of pi, and the sine of pi over 2. So let's sketch a unit circle again. So we have 1, 0, 0, 1, negative 1, 0, 0, negative 1. So the sine of 0 degrees. Now let's think about, what does a 0-degree angle look like? Well, it's going to look like this, right? It's the initial ray and the terminal ray are just going to live on the x-axis, right? Because that's an angle of 0. It's just a ray. And look at what point it goes through on the unit circle. It goes through the point 1, 0. And sine, remember, sine of theta or sine of t is equal to y. So sine 0 is going to be equal to y. And what's that y value at that point? It's 0. So the sine of 0 degrees is equal to 0. And look, the calculator is going to tell us the same thing. So let's go to the calculator. Make sure you're in degree mode. And now let's type in the sign of 0, and we get 0. What about the cosine of 90 degrees? Well, a 90-degree angle, so I'll do that one in green. So a 90-degree angle, right? The terminal ray is going to coincide with the y-axis, and it's going to go through the point 0, 1, right? This is a 90-degree angle. And cosine is equal to x, right, in a unit circle. So the cosine of 90 degrees is going to be equal to the x value, and the x value in this case is 0. And we could confirm that on the calculator. So look, let's go to the calculator, type in cosine of 90 degrees, and we get 0. What about the tangent of 270? So let's use pink. So tangent, well, first of all, let's sketch a 270-degree angle. So that's going to be the angle where we go 3/4 of the way around the unit circle, right? So the terminal ray coincides with the y-axis, and it goes through the point 0, -1, where 0 is x, y is -1. And tangent is equal to y over x. So the tangent of 270 degrees is going to be y over x, where y is -1 and x is 0. And we can't divide by 0, right? So the tangent of 270 degrees is undefined. And if we try to go plug that in the calculator, we're going to get the same answer, right? If we try to type in tangent of 270 degrees, the calculator is going to say there's an error, and it's because we're dividing by 0, so it's undefined. What about cosine of pi radians? So now we're in radian measure. And pi radians coincides with the x-axis, right? If we were to go halfway around the unit circle, we'd form an angle of pi. And that angle is going to go through the points -1, 0. So x is -1, y is 0. And cosine, remember, is equal to x. And x in this case is -1. So the cosine of pi is equal to -1. And let's confirm that in the calculator. Make sure you're in radian mode now, though. So mode, let's go back to radians. And we want the cosine of pi. And we get -1. And we'll do one more. The sine of pi over 2. So let's clean this up a little bit. So pi over 2 is equivalent to a 90-degree angle. So let's go back to green. It's this angle right here, right, where the terminal ray coincides with the y-axis. So the terminal ray is going to go through the point 0, 1. And sine is equal to y, and the y value at this point is equal to 1. So the sine of pi over 2 is equal to 1. And we could confirm that in the calculator. So we're in radian mode, so we're going to do sine and then pi divided by 2. And we get 1. So the unit circle is very helpful to us. But realistically, when we're looking at applied problems and stuff, we're not always going to have a radius equal to 1 unit. It's nice, but sometimes that's just not the way that it is. And in that case, it's all proportional. So the last thing that we're going to look at is the graph of the domain, the graph of the sine and cosine functions, and we're going to look at the domain and range. So we're going to look at the properties because I think that's really important. So all along throughout the semester, every time we, would learn about a new function, I stress the importance of the graph, its characteristics, the domain, the range, any intercepts. So let's look on the left. On the left, we have the sine function. So let's just say y equals sine x. And, normally when we're working with a function, the input is x, the output is y, right? So y is a function of x. And it's common that we're going to be in radian measure. So that's why you see the scale on the x-axis, it's in radians. We have 0 at the origin. Then if I read to the right, we have pi over 2. Then the next comes pi. Because each one of these tick marks, let me do this in a darker color, is pi over 2. So another set of pi over 2 would be 2 pi over 2, which is just pi. Then we have 3 pi over 2. Then we'd have 4 pi over 2, which is just 2 pi. And we could go in the negative direction also, like this would be negative pi here. So my x-axis is in radian measure, and we're counting in increments of pi over 2. And this makes sense because look, let's go back up here. You see how we just did this last example, E, the sine of pi over 2 is equal to 1. Well, look, go to pi over 2 and look where it hits the graph. It hits the graph at y equals 1. The sine of, let's say, for example, 3 pi over 2 is equal to negative 1. Which makes sense because look, 3 pi over 2 is equivalent to 270 degrees. So if I were to go 3/4 of the way, right, around the unit circle, my terminal ray is going to be quadrantal, right? It's going to land on the y-axis. And the sine of 3 pi over 2 is going to be equal to y, which is negative 1. You see how it goes through the point 0, negative 1. So that's what the graph of y equals sine x looks like. It's oscillating or periodic. You see how it's repeating? And notice, let's just clean this up a little bit. The highest value that sine could be is 1, and the lowest value that the sine of x could be is negative 1. You see how this graph oscillates between 1 and negative 1. Therefore, the range is going to go from negative 1 to positive 1 inclusive. And then x, the domain, for what are the possible x values for the sine function, it's going to be all real numbers. So you see how this graph just continues indefinitely, right, in both directions. So it could be sine, x could be any angle, in other words. But the output, y, is going to oscillate between negative 1 and positive 1. So the domain is going to be all real numbers. The range goes from negative 1 to positive 1. And period, which we're not really going to talk too much about in this class, is look at from 0, we go up, down, and then back up, and we're right back where we started. And then now we would see another mirror image, right? So what is it to complete one full revolution, right? So it's from 0 to 2 pi. So that 2 pi is the distance. So it's the period. Now the cosine function looks very similar to the sine function, right? So on the right here, we have y equals cosine of x, but it just looks like the graph of sine, but shifted to the left, right? You see how this peak over here looks like it's shifted to the left and it's sitting on the y-axis, right? So it has a y-intercept. So notice the y-intercept of y equals sine x is at 0. The y-intercept for cosine x is at 1. So for example, like this value is pi over 2. This point right here is pi over 2, 0. So what's the cosine of pi over 2? Well, it's 0, right? We looked at, oh no, we did sine pi over 2, but let's look at cosine of pi over 2. Pi over 2 is this 90-degree right angle, right? Pi over 2 is equivalent to 90 degrees. And that point, that terminal rate goes to the point 0, 1. And the x value is equal to 0. So the cosine of pi over 2 is 0. And look, it's sitting on the x-axis, right? So the y value is 0 when x is pi over 2. So the range is also the same. The range for your cosine function is from -1 to +1 inclusive, and your domain is all real numbers. And the period of your cosine function is also 2 pi. It's the distance from peak to peak. So that pretty much wraps up section 1.4. You'll have homework on the concepts that we went over in this section. And then we'll move on to the next trig section in the next video.